and then comes the TTR or transformer turns ratio. So usually all these three tests, core balance, uh, transformer turns ratio test, I mean voltage ratio test later on, and the vector group test. Three usually test is being done through an instrument called TTR instrument, and the turns ratio you see in everywhere. I have told you the 33 kV by 11 kV by 3 root 3. If you see, so 33 by 11 kV by root 3. If you see the 33 by 11 into 0.3, it comes around 5.19. So whenever I use to voltage, you see the turns ratio V1 by V2 is equal to N1 by N2. So by using the turns ratio, we can select whether this transformer voltage ratio is perfect or not. If it comes 5.19, then we can come to the conclusion that voltage part is also okay. 33 by 11 kV ratio is already there. So using this three particular TTR instrument, we can use these three tests one at a time. Then comes the magnetic current test. It is a very important test for us. The magnetic current test usually we do for the transformer to see whether the magnetizing current for no load loss is properly working or not. That means the core is properly working or not. So what we do over here, we usually do the exactly the magnetic circuit to know the effective establish a flash in the core or to activate the magnetic circuit. What we do the current flows to the primary transformer with specific voltage and frequency, and 11 side LV side keeps open. Once we keep 11 kV sides open and put the 33 kV voltage to the transformer side, so we use through the meter, we try to measure the total power, that comes the total loss, and usually we focus on the magnetizing current, and that usually comes for the new transformer. It is coming 6 to 10 kiloampere, but in that particular case you see, in that particular case you see the IR, IY and IB, it is going to 30 milliampere for different tap position. Why it is happening? Because it is very old transformer. For the new transformer, we experience that 6 to 10 milliampere usually see the magnetizing current happens. If in proper way testing, if see the magnetizing current comes to 6 to 10 milliampere, that is okay for us. But in case of old transformers, it may go to 30 milliampere and beyond, but it should not be go to the ampere range. If it is in ampere range, then we say that the magnetizing current is faulty and the core is not proper acting. Then comes the polarization index of the test. It is basically the insulation of the material. Test for the insulation of the material. This is called the polarization test. Basically, we usually the insulation measurement, we do it in the Megger. You know the Megger is an instrument, and that can generate the DC voltage when you priming it. And there are two types of Megger we use: 5000 volt Megger. Hello? 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 Hello?
Yes, sir.
Yes, sir.
Certain
Yes,
humming
audible,
sound
audible.
is.
Yes, sir.
Okay. So when we use the Megger HV side, we use the 5000 volt Megger or 5 kV Megger, and we use the Megger for 10 minutes. And for the LV side, we use the 1000 volt Megger, we use for the 10 minutes. And then again HV side we go and use the Megger and we do the test for the 1 minute. So the result we get, the insulation ohm resistance we get in mega for 10 minutes and the 1 minute, we usually divide it and it should be always greater than 1. That means the mega result of the insulation for 10-minute test using 5000 volt mega and mega result for 1-minute test, if you divide these two, it should be always greater than 1, then the polarization index is correct. And this should be done in HV system, LV system, HV2E and LV2E. That means 2R. That is the polarization index we usually do. Then here are certain situations why we do the insulation test so frequently or so importantly, that I have been explained over here. If you apply this voltage across the insulator, there will be corresponding current through it. Although the current is very small in milliampere range or microampere range, but why this current is flowing if it is absolutely insulated material? It is because of 4 components it has: that capacitive component, conductive component, surface leakage component, and polarization component. These 4 components usually are the reason to, I think, figure out this current, although it is milliampere or microampere range in case of polarization test. If we denote in IC plus IR plus IS and IP, hence the total current should be I. So value of insulation resistance test or IR value test or mega reading just after 1 minute of the test, if R1, then V by IR plus IS plus IP and the mega for 10 minutes test in case of V, IR and IS. Therefore, the result of the polarization index would be R10 by R1 as I told you, and V by IR plus IS by V by IR IS plus IP. In that particular case, if you ruled out the V in that sense, then IR plus IS plus IP by IR plus IS. If you divide these two, it comes 1 plus IP plus IR plus IS. That means it should be always 1, greater than 1. That is how we design that polarization is perfect and insulation is perfect. So this is the show of polarization index for certain things. Suppose if you go for the 1 minute test, for HV2R, it is 8.23, 4.2 mega ohm. For HV2 LV, it is coming 6.59, and LV2R, it is coming 4.82. And the same test is being done for 10 minutes. It is coming 12.9 for HV2R. HV2LV, it is coming 12.2, and LV2R, it is coming 8.83. Now, if you divide these two, 12.9 by 8.23, it is always greater than 1. 12.2 by 6.59, it is always greater than 1. In much greater than 1. That is, insulation is very good. And 8.83 by 4.82, it is almost close to 2. That is, insulation is very good. In that way, by polarization index test, we measure whether insulation is perfect or not. Now I will talk about the type test. 3 tests are carried out only on 1 transformer of the lot. Lot means maybe I am procuring 100 transformers. Or in that particular case, I choose randomly 1 transformer. I usually do this test. And if the test persists and the test results are okay for us as per the specification or IS standard, so we can consider it that this particular lot of the transformer is okay. That is why it is called type test. In type test, all routine tests we provide, usually I already mentioned. So certain type tests we do, lightning impulse test and temperature rise test, that I will discuss. And some special tests we do over here: additional impulse test, short circuit test, measurement of zero phase sequence impedance test, measurement of acoustic knowledge test, measurement of harmonics of the no load current, measurement of balance test. So these all are not the situation, or maybe time will not permit to discuss all these things. So I will skip all these tests. Then I'll go for the oil BDB test I have told you. The oil breakdown voltage for insulating oil. This is as per the standard IS standard 335. What we do, we take a glass pot of 100 mm of length, 75 mm of breadth, and 80 mm of height. A glass pot we take. 500 ml oil sample we collect from the transformer, and the spherical electrode with gap of 2.5 millimeter we put, and we recommend the voltage to the spherical electrodes. We apply the voltage usually 60 kV. If it withstand the oil BDB test set, we say that oil is good. And if it is even if it is below 45 kV, if it is oil breaks down below 45 kV, in that particular result, we said the oil is contaminated, for the reclamation or refining or change of the oil. Now we come to the short circuit withstandability test as a special test, as I told you. This test measures the ability of the transformer to withstand the mechanical and thermal stress. Mechanical thermal stress, when the short circuit current flows, there is a huge stress developed in the transformer because of the high voltage and magnetizing force developed in the transformer. So in that particular test, we see in that short circuit period, although it is a very short period of time, the short circuit current flows to the transformer, but still whether the mechanical thermal stress developed due to this reason, whether it is capable to withstand all the stress or not, that particular test is being done through this test. Okay, so what we do usually, HV terminals are connected to the supply bus for the testing, and LV is short circuited, and testing plan parameters are adjusted to give the rated short circuit current. Supply is made and closed over specified duration of the short circuit, and record current wave is noted. And we see if there is not any mechanical distortion and fire during this test. Similarly, no waveform distortion we see in the oscilloscope. And in that particular test, we see the reactance of the winding measured before and after the short circuit test, and we see whether it is going beyond the limit or not as per IS specification 2026. Then comes the lightning impulse test. It is another type test. What we do in lightning impulse test, it is a very important. Lightning impulse test we do, we provide the lightning, suppose to see whether transformer is very much withstandable to the lightning impulse. We usually do this test. Voltage in three-phase transformers, impulse is carried on all three phases in succession. What we do, we usually use a machine which chop the sine wave, and that amplifies to some kV level, and that is being applied separately in separate time succession in each phase, and see whether it can withstand or not. And the entire wave shapes, current and voltage, is being seen or observed in oscilloscope. I will show you